What's up, everybody? This is Matt Brown with another IoT hacking video. Today we are going to discuss a bug class that has earned me 5 figures in bounties over my career as a bug bounty hunter. Let's jump into it by navigating over to my screen and doing what I like to do best, and that's look at some network traffic in Wireshark. So over here, I have an application running on a Raspberry Pi. So unfortunately, because of the nature of bug bounty, I can't discuss with you the exact findings of a specific device that I have found these vulnerabilities in. That's the way bug bounty works most of the time. But I'm going to talk about the general bug class, and we're going to introduce it with this PCAP. So when looking at this network traffic coming from an app that I have mocked up and installed on this Raspberry Pi over on our desk, we'll see when the device boots up, a number of things happen. So first, we see a DNS request, right? This is pretty standard. DNS is the protocol that the internet uses to take human-readable names, in this case, 2.debian.pool.ntp.org, and it's going to translate that into an IP address, right? And so here, it's actually doing an IPv4 and IPv6 lookup, but we're only going to pay attention to the IPv4 stuff today. We can see here that it actually was able to get a response here, and in the answers section, there are actually 4 different IP addresses that it says this name resolves to. So that's DNS. That's nothing fancy. And DNS, as you can see here, is not encrypted, and it is unauthenticated by default. This is a protocol that has no security built into it. Now, there have been bolt-ons that have been created later. We have Nahamsec, where the DNS responses are signed, and then the client can verify those signatures. Or we have DNS over TLS that encrypts and signs those DNS responses, and so it provides confidentiality and integrity. So that is DNS, but most of the time we don't use those secure protocols, right? That data is untrusted, but that is not a big deal because in the internet at large, we do not trust DNS, right? And because it's untrustworthy, we account for that by creating trust after the fact. So when a client connects to a server on an IP address that it did a DNS lookup for, it does not know if it's talking to the real server or a bad guy pretending to be the server. And what we do to verify that is we use TLS, right? We have the PKI, the public key infrastructure, where there are CA authorities out there who will verify if you own a domain, and then if it verifies you do own that domain, it will sign your certificate and put its stamp of approval on it cryptographically. And then when the client makes a connection to that server with that server certificate, the client can verify that it is who it says it is, that server. But there's another protocol. So I would say in 2024, the year 2024, there are 2 protocols that we still let run around unencrypted on the internet. The first, I've just talked about, DNS. I've talked about how it's untrustworthy and how we account for that, right? We paper over that. We account for it by providing trust in a different way, right? But there's one more protocol, and it's the next protocol right here in this PCAP that also is allowed, by and large, to just run around unencrypted, unauthenticated. It's not signed, but we don't have any secondary mechanism to follow up and build trust. And so that is the NTP protocol. So right after this DNS request, funny enough, we see these NTP requests and responses. So if you're not familiar with the NTP protocol, it stands for the Network Time Protocol, and it is the way that a computer system can sync its clock to some more trustworthy clock out there that has the exact time down to some very fine grain level of detail. And we really don't care about the fine grain nature of that detail, but when the client gets this response back in our PCAP over here in Wireshark, let's go ahead and actually make this bigger. So we have these NTP requests. So here we can see NTP version 4 is that we have client and then server. So the client says, hey, what is the time, right? We're gonna simplify this protocol for the sake of this video. And then the server will come back and say, hey, look, it is October 28th, which is the time as I'm recording this video of 2024. And the client will just accept that. It's not encrypted. It is not signed. There is no real way that we can trust this data as the client. Now, most of the time, this is not as security critical as DNS is, right? There's less that we can do if an attacker can manipulate what time your system is, especially with a computer. It's kind of hard. It's not as clear-cut of an attack path. And this is why things like web applications, man-in-the-middle attacks, if you look at a bug bounty platform, if you look at their list of bugs that are out of scope, that they do not consider valid bugs, they're not going to pay out for them, they're going to close them as NA or informational, right? Man-in-the-middle attacks are on that list. But with mobile apps, and even more so with IoT devices, which is what we talk about on this channel, they are relevant, right? Because an attacker might be on the same network as that device and then could easily get themselves into a man-in-the-middle position where they're able to manipulate traffic that device sends out to some server somewhere. And in this case, that is the network time protocol server. So we are going to discuss a class of vulnerabilities where we can manipulate what time a computer thinks it is. So we are going to do some time traveling today, all right? And so what I have here, first I want to, really reference what we're looking for if we want to find a bug that is impactful, if we can manipulate NTP. Just because you find a device that's in a bug bounty program and you see that it's using NTP to get its time data, that alone doesn't mean that you're going to be able to have a real impact with the finding of this insecure protocol. So I am going to link this awesome talk in the video description of this video, and I want you all to go watch this because this is some very simple methodology that Archangel, real name Douglas Day, awesome bug bounty hacker, he lays out this just extremely simple principle of finding authorization type flaws, and that is this idea of looking for the no's, right? When we look at an application, we want to see where is it telling us no, you're not allowed to do this thing. And then we want to look, and then what I want to talk about today is you want to look for the different ways that it's telling you no. So I have written a demo application here. Like I said, this is running on a Raspberry Pi over here. Got some setup instructions, and here we have the PHP source code that is associated. Let's make it so you guys can see that. Perfect. All right. There we go. So here we have a very simple PHP script that we are going to be attacking today. And you'll notice what it does is it gets the date, it gets the current, system time. It's going to parse it out for printing it out later. But the key thing is a very simple application. Right here, this application is saying if the month is equal to 1, if the number of the month is equal to 1, and the day of the month is equal to 1, or in other words, if it is January 1st, then it's going to allow you access into the system. But if it's not January 1st, you're going to get an access denied message, right? So this application is making a decision to allow you access to a system or to not allow you access to a system based on what time it is. And if the underlying system is using NTP to figure out what time it is, then we can attack the system and have some kind of impact because of that insecure time protocol. So we are running this application right here. Let's blow this up here. So when we navigate to the site, you can see it takes no input. The only real input is time itself. And so it's not January 1st. We would have to wait a couple months under normal circumstances to be able to access this page. But because this is running on a Raspberry Pi that is using, by default, I didn't configure anything weird on this Raspberry Pi. This is what it uses by default to ascertain the system time, is the NTP protocol. And so we're going to use that to conduct a man-in-the-middle attack and to get us access, to get us access granted to this page. So to do that, we are going to use a couple of tools. So over here in the README file, I talk about the two tools that we're going to use. One is man-in-the-middle router. This is a tool we've talked about in this channel before. All it's going to do is it's going to help us to spin up a bridge interface, and then we're going to plug our IoT device into that bridge interface, and it's going to help us to conduct this man-in-the-middle attack. We've talked about this on this channel before. I've done whole videos on man-in-the-middle router. Go check those out if you have any questions. But DeLorean, so this is this really cool tool out here. So man-in-the-middle router, that's my tool. DeLorean is a tool written by another really smart hacker. And this is an NTP man-in-the-middle tool. And essentially what it's going to do, it's going to have us spin up an NTP server, and then we can tell it to think that it's whatever time we want it to be, right? So we can tell it to, offset whatever the current time is by a certain amount, or we can just always say it's the same date and the same time, and that's what we're going to be able to do with this tool over here. So I have that set up right here. So again, we've kind of already covered the PCAP from the base case. You see the NTP request. It gets a valid response from the real NTP server out there, and we are not allowed access. But now what we're going to do is we're going to stop man-in-the-middle router, and we're going to go down into the config file where we have all these optional man-in-the-middle rules, and we're going to set an IP tables rule that looks like this. So let's make sure this is nice and big. Okay, you can see this, awesome. So here we have this rule that says we're going to create a pre-routing rule on the bridge interface, and we're going to look for traffic that is using the UDP protocol, and it has a destination port of 123. That is the default NTP port. And then if it sees traffic going out to that port and using that protocol, then we're going to redirect it locally on our computer to port 1234. So up here, using the DeLorean tool, we are going to use the -D flag to set it to this year, but January 1st. And we're just going to say it's 12 noon because it's actually it actually sets it in UTC, so it's going to like offset it in one direction or the other. And then the -P flag says that it's going to run on port 1234, and then that's going to sync up with our IP tables rule here. So we're going to run DeLorean, and you can see the awesome ASCII art that gets printed out here. So we're going, in man-in-the-middle router, we're going to save that, and then we're going to rerun our man-in-the-middle router script. And now what I'm going to do is I'm going to prepare Wireshark to start capturing again on that bridge interface. And all I have for the filters up here, if you're curious why I have these filters, I'm just filtering for the Raspberry Pi's specific IP, and then I'm filtering out SSH traffic because that's just a bunch of noise. All right, let's make sure that's nice and big. And now what we're going to do is we're just going to unplug our Raspberry Pi, and then we're going to plug it back in. And then in a few seconds here, we should start to see traffic, and we should be good to go. All right. here we are. So it's just starting to connect. We're going to see down here. Okay, so and then in the DeLorean script, when it gets a request, right, like that, we get a response and it says we are going to the past. So we have now changed the time. We've now issued a malicious response using the NTP protocol to make the Raspberry Pi think that it is January 1st. So if we look at this PCAP, and Wireshark is glitching out on me, but here you can see that it did get the NTP request and response. And then if we go back to our web app here and we refresh the page, access granted. So again, looking at our code here, if we go back to our index.php file, here, again, it's really obvious what's going on here. The PHP, again, it's querying, it's just calling down to the system, the underlying Linux system, and says, hey, give me what time it is. And then because the system relies on NTP, now the app thinks that it is January 1st, and it goes into the first block in this if check. And that is how we are able to manipulate access control systems. So if you're looking for impact with NTP protocols, right? There are some systems that might use NTP to get what the time is on the underlying system, but it won't actually use it for anything that you can really show like a big impact on an IoT device. But devices where you want to start thinking about time in terms of access control, any kind of system where you can create a user with limited access, right? That's actually what you want to look for. You want to look for a system where you can create a user with limited access, where that access is only allowed during certain times. This is a big feature on smart locks because a lot of people want to give maybe, their cleaning people, a contractor, access to their home because maybe they're not going to be there during the day, so they give them a code to their smart lock. But these smart locks have the ability to limit that code from being able to unlock the door to a certain time of the day. Well, it's a pretty plausible scenario that those same people might be able to, either maliciously or because you give them your Wi-Fi password, they might be on the same network as your IoT devices that rely on NTP, and then could perform a man-in-the-middle attack like this to get themselves access back to that property at a time where their user is not actually allowed to get access. So any kind of access control systems that have that type of limitation. Also think of any products that have parental controls, that have, where they can access, maybe it allows them to access the internet or to access certain resources during certain times, but doesn't want to let them, access those resources at 2 a.m. in the morning, perhaps. Look for those types of reduced access levels and accounts, and then see if you can manipulate time and you can gain yourself access to something. Thank you for watching this video, and I hope you too can use this out there to go get some awesome bug bounty money. So have a good day. Please like and comment on this video. I appreciate all your feedback. Let me know if you want me to do more videos like this explaining general bug classes that I have success with in bug bounty. Thank you and have a good day.